Good afternoon, I'm Matt Moot, this is Ken Young, and we did the lowest observable adverse effect level of ammonia. And first off, our hypothesis was that ammonia will have a positive effect on the growth of the plants because, from personal experience actually, we've used them on crops and such, so they've actually enhanced the growth of whatever we put it on. Because the element combination of the two would be NH3, and of course everything needs nitrogen to grow, which would affect it. And hydrogen also comes from water and everything, so that would also enhance the growth. We said at 3% it would have positive effect on it, but as we went up the scale, at 10% we said it would have an adverse effect. And of course our null hypothesis was the concentration of 3%, 10% would have absolutely no effect on it. And talk about what we did in our methods and our materials.
Okay, so to start our experiment, we took 15 planting pots and we gathered enough soil by scooping the soil with our pots and putting it into a bin. And then we mixed then we mixed our water with the contaminant depending on, like, for trial A we did 1%, trial B we did 3%, C we did 6, and D we did 10. And we mixed it with 150 milligrams of water. And then we mixed it each percent with, like, whatever trial was. So if we did like 1%, we did with the first, like, 3 pots, and we did 3% in the next 3 pots, which was trial B. And then we did that all through trial D. And then we put 10 seeds in each pot. We put them about a centimeter down in the soil. And then we set them on the tray. We labeled them accordingly to the trials. And then we let it grow for a week. And what we did differently from a lot of the groups, which I thought made a difference, was we only watered them twice, 100 milligrams each time. A lot of groups saw that they watered them at least like 4 or 5 times, and they overwatered them a lot of times. We ended up having to do an extra trial, but Adam's going to explain that.
As you can see in our graph and part of the results, because all of our plants actually grew, and they grew kind of at the same rate and had the same height, we couldn't really say there was a mean height to all of them, so we just put them all as how much grew in the pot and where they decreased at. So it might have been our mistake for some of it, that some of them only grew 9, we might have mixed up the numbers of seeds, but at 10% they were still growing at a very high rate, so we actually did a next trial E, which was later planned the next week, and we've actually put 20% of ammonia within the 150 milligrams of water, and seeing that would be our LO, lowest observable adverse effect level, in between 10% and 20%. We didn't find out the exact percent, but in between that level, that is where we found that they had adverse effect. Throughout the week, after watering it and everything, we found out that that was true. And yeah, that's all I got.
So it's about 15% we hypothesized. I mean, like, after you're done, between 10 and 20. So
yeah, we just threw it 15 or so. That was our basis. And that's it.
Question. So I'm a little confused about your measurements. So explain again why are all the measurements the same there?
Right here?
Yeah.
Because that's the actual number of plants in each pot.
So that's not the length of the blade, that's
no, because
the number that germinated.
It was really weird because throughout each trial, most of them they range between the same exact numbers. So we thought, to like not have much confusion, just put how many grew, and then the next trial we could see. You could totally see how far it went down after the 20% was at.
Did you actually calculate that data? Did you measure the actual blades of grass?
Yeah, we measured every single one, and they were pretty close.
They were all,
it was
for the first time, because like they all grew a lot, and it was like really similar to all the trials.
So how did you compare them statistically?
By this or?
Yeah, what method did you use to decide, yes, there's a difference between the control and the experiment or not?
Well, that was a t-test that we had that showed that between, actually our hypothesis was really close, but it wasn't as close as we wanted it. Actually 1% was the biggest increase, but then 3% was just little, it was almost where you couldn't really tell. So that's why we did it like that.
So why did you choose 20%? Why did you decide to do that?
Because as you can tell, 10% it's still, you know, running with these ones. So we said, why don't we just try to kill them?
Yeah, we wanted to kill
So we
them
went,
at that point.
and it's, you know, at small amounts, ammonia is helpful, and you don't need to, I mean, you still need to wear protection, but not as much as you would for that, so it could cause more harm as a higher dosage.
So why not 30% or 50%?
Because I don't think anything would want to grow to them. It would just be dead. For sure. So,
Thought that would be overshooting.
yes. And as you can tell, it pretty much did a pretty good range from that.
Other questions? So what are your recommendations then in terms of implications for using ammonia?
Me, I would use it if you want something to grow better and don't have much experience in growing stuff, but you have to be very careful with it. It can, like I said, it could be harmful to humans if you don't use it properly. And that's why, as us, you know, farmers and all that stuff, I don't actually use it. I let the companies that are trained to use it properly. So that's what I would.
So do you use it on your farm?
Yes.
Do you just take ammonia and put it on the fields?
We actually have, there are anhydrous ammonia tanks. There's anhydrous in front of it because it's just a little bit of water, and it's only a small amount of the tank. And we knife it in the ground, which is these blades, and we just put it direct, instead of spraying it, broadcasting it, we directly inject it into the ground.
And what does anhydrous mean?
It's water, it's, right?
Without water.
Oh, I'm sorry.
Kendall, what would you say about if you were to do this again, what would you do differently?
I think if we did differently, we obviously would choose different levels of contaminant for the first, like, trial. We would have not started at 1%, obviously, because it didn't have any effect until, I think I would have started more at like either 10% to like maybe 30 or 40, instead of starting at 1 and going to 10. So we could have seen like where like it actually killed it and when it wouldn't have any growth at all.
And compared to other contaminants here, where would you put yours? Is it a bigger worry or a smaller worry, or?
In large dosage, it would be more worry. Because, well, that sheet that you gave us, it said it could, you know, it could pretty much eat through skin if you really wanted it to. It's at high dosage, yes.